Hello, good morning everyone. So today we are going to discuss types of learning algorithms. In fact, we have started discussing types of algorithms in the last session. We are going to continue our discussion. So as we have seen earlier, we are having three important kinds of learning algorithms. What are these three types? We are having supervised learning algorithms, unsupervised learning algorithms, and reinforcement learning algorithms. So what we mean by supervised learning algorithms? Supervised learning is similar to that of a learning with teacher. What we mean by that? See, for example, in supervised learning, we are having some known facts with us. We are having some training data, which is pre-labeled. So what we mean by that? We have seen earlier one example of housing data set. So what we had in housing data set, we had 4 attributes. Those were describing some properties related to the house. And the 5th attribute was the price of that house. So depending on some parameters, there is associated some price. Okay, so this entire data, the attribute values for the house along with the price, everything is known to us. So in supervised learning, our algorithms are actually using such kind of known data, pre-classified or pre-labeled data, right? That is called as training data, and it is of the form x comma y. So here x represent the attributes, right, for which we are knowing the values, and y is actually the prediction. Okay, so for whatever is the data, we are knowing the predicted values also, and this is why it is called as supervised learning, because we are knowing everything, right? Something is there that actually help us to know the data, to know the outputs also, to know the answers also. We have seen in machine learning paradigm that whenever we go with machine learning paradigm, the input is data along with the answers, data along with the labels. So X stands for the data and Y stands for the associated labels or the classes, whatever it may be. So using such kind of training data, our supervised learning algorithms actually learn from that data, okay, and prepare some rules or models. And after preparing the model, what happens is, whenever there is some new observation, whenever there is some unknown data, then using that learning, our algorithm tries to find out the best suitable label or the best prediction for that. Okay. Now, under supervised learning, we are having 2 categories of the algorithms. These are known as the classification algorithms and regression algorithms. So we are going to focus upon these categories a bit later. But let us see here, we have mentioned few of the applications under classification and few of the applications under regression. So the applications under classification are, say, identity fraud detection, image classification, customer retention, diagnostics, and so on. So in all those applications, our prediction is in the form of a class, a label. So if I'm talking about diagnostics, what kind of output I am expecting in case of diagnostics? I may have the output like yes or no, whether the disease is present, yes, or not present, that is no. Or I may have multiple classes also, whether the disease is of grade 1, grade 2, grade 3, and so on. So this kind of a problem is known as the classification problem, and that comes under the supervised learning algorithms. The next category of supervised learning algorithm is regression. So the applications are like advertising, popularity prediction, weather forecasting, market forecasting, estimating life expectancy. So what we can observe out of these applications is, in regression applications, we are not actually predicting the class, but instead we are predicting some continuous value. Say for example, the problem that we had dealt with earlier, that is the house problem of predicting the prices of the houses, that problem comes under regression because we were predicting some value, we were predicting the price. We are coming to that a bit later. But remember that classification algorithms are actually providing us the output as a discrete value, a class or a label associated with the data, whereas in regression problem we are predicting some continuous value, some real value. Okay, so that was related to supervised learning. Now if we talk about unsupervised learning, we are having the clustering algorithms under unsupervised learning. So what we mean by clustering actually, and what are the unsupervised learning algorithms? In contrast with the supervised learning, in unsupervised learning, we may say that it is a kind of learning without a teacher. What do I mean by that? In unsupervised learning, we are having provided with only the data X without labels. So whatever data we are having is of the form X. That means I am having only the attributes related to the observation, okay, and the values related to those attributes. But I do not know the answer for that. So in unsupervised learning, we are having the data of the form X. We are not provided with the labels. Okay, and what our unsupervised learning algorithms will do? If I am having set of data, unlabeled data, based on that data, unsupervised learning algorithms try to analyze that data based on the attribute values. So whichever are the observations or whichever are the samples in that data set, those are similar to one another. I'll repeat. The observations, those are similar to one another. Those will be grouped together. And we say that it is a cluster. Okay, so in number of clusters, our data gets divided or our data gets segregated among various clusters depending on the similarity between the data. Are you getting me? Yes? Please speak up. Are you getting me?
Ma'am, can you repeat please?
Okay. So have you understood supervised learning?
Yes, ma'am.
Okay. So I'll be repeating unsupervised learning. In unsupervised learning, what we have is, we are having the data set without labels. Okay, so for example, I just want to see, let us assume that in this class, I am having the students, those belong to 3 different branches. Okay, but I do not know which student belongs to which branch or which discipline of engineering. I do not know that. So whatever my data is, that data is unlabeled. I do not know the class of that data. I do not know the branch of my student. So let us assume that this branch is the class and I am unaware of the label associated with the student. I do not know from which branch the student is. And what I want to do is, I want to apply some machine learning algorithm to group the students belonging to one branch of engineering together. Okay, so what I would like to do is, I would like to form 3 clusters. One cluster for electronics students, one cluster for electrical students, and one cluster for aeronautical students. Okay, so what I'll do is, I'll collect the information related to all the students in my class. So what kind of data I'll be collecting? I'll be having some properties. I'll be having some attributes defined. Those will be helpful for me to segregate this data. Okay, so based on the values now associated with every student, so I will be having the data set, meaning I'll be having the number of records equal to number of students in my class, and every record will have some values related to the attributes defined, related to the properties defined. So what I'll do is, I'll use some unsupervised learning method, and this method will help me to group the students having same properties or similar characteristics. Okay, so whichever are the records, those are very similar. I'll be collecting those records in one cluster. So this is how my unsupervised learning algorithm will work. So it will data that is most similar. And this is how it would be possible for me to have 3 clusters of the students. Those belong to 3 different branches. Are you getting me? Hello?
Yes, ma'am.
So got the concept?
Yes.
Fine. So under unsupervised learning, we are having the clustering algorithms, and typically the applications of unsupervised learning are the recommender systems, targeted marketing, customer segmentation, and many more such kinds of applications. We are going to focus upon such applications later under every category. Okay. Also, we are having some mechanisms to reduce the dimensionality of the data. I'm not going to talk about this dimensionality reduction algorithms right now. We'll be focusing upon these kinds of algorithms later. Okay, in unit number 3. So I hope you must have understood so far the supervised learning mechanisms and unsupervised learning mechanisms. Now the third category of the machine learning algorithms is reinforcement learning. So what we have in reinforcement learning? In fact, the reinforcement learning we are not going to focus upon in this introductory course of machine learning. In reinforcement learning, we have something like called as agent, and that acts in the environment. Okay, and those agents actually take these steps based on their experience. Okay, and if whatever is the move of that agent, if it is correct, then the agent will get the reward, otherwise the agent will get the punishment. So the reinforcement learning has the concept of rewards and punishment, that is the positive reward or the negative punishment or penalty, and based on that the scores are being computed, and depending on that score, whichever is the maximum score, that move will be identified as the correct move, and accordingly the system learns. We are not going into the details of reinforcement learning right now, but let me tell you few of the applications of reinforcement learning. Many times while building the games, there is a need to learn based on certain history or certain moves those are being performed in the past. So based on that experience, actually the model learns. So building the games or robot navigation or sometime having the real-time decisions, we find the applications of reinforcement learning. So just remember here, in reinforcement learning, we are trying to maximize the reward based on certain situation, and whichever move is actually giving us the maximum reward, that move is picked up, right, to come up with the solution. So that is what our reinforcement learning is. So let me tell you that other than these three, supervised learning, unsupervised learning and reinforcement learning, we are having one subcategory, and that subcategory is known as semi-supervised learning. So supervised learning, unsupervised learning and reinforcement learning are three major categories of machine learning algorithms. But we are having one small subcategory, you may say, and that is a semi-supervised learning. So semi-supervised learning is the combination of supervised and unsupervised learning. We are going to focus upon this concept a bit later. This is only for your information. So I hope you must have understood what we mean by supervised learning, what we mean by unsupervised learning, what is reinforcement learning, and what is semi-supervised learning. So we are going to focus upon these categories a bit more details. Okay, so let's begin with supervised learning. So see here on the screen what we have. As I mentioned, in supervised learning we are having the labeled data. So whatever right now you are able to visualize here. So this is our labeled data or our training data. So our training data comprises of X and Y. What is X? X is input, and what is Y? Y is the output. Okay, so I'll be having the input output pairs, right, for all the observations in my data set. So this is called as the training data set. In training data set, I'll be having n number of samples of the form X comma Y. X is input, Y is output. By making use of this data, my algorithm will learn. So this data is applied to the learning algorithm. and my learning algorithm will learn out of this training data which is labeled. We are having known the class or the prediction for the inputs. Okay. Now, after learning, supervised algorithms actually come up with the model. So this is the model that we have. Okay. So learning algorithm will provide us the model. So model is actually a mathematical function. Okay, we are going to focus upon the learning algorithms. Those are actually building various different kinds of models. So model is nothing but a mathematical function that has been used for predicting the output for unknown data. So once my model is created, I'll be providing new input X. So this new input is the unknown input, unknown data, unknown X. Okay. So I'll be providing this unknown X to my model, and based on whatever is learned, my model is going to provide me the output Y. So this is a simple representation of supervised learning technique. So what we are having training data that comprises of the data of the form X comma Y. X is input, Y is associated output. So I'm having n number of data samples in my training data set. My learning algorithm uses that training data set to build the model. And whenever new input is provided to the model, my model will predict the output Y. Okay. Now, let us once again focus upon the same example that we have earlier gone through. So let us assume that we are having this housing data set. For simplicity of the discussion, we have mentioned here only 6 records. So we are having only 6 records. Okay, or we are having data related to 6 houses. In fact, my training data set comprises of many records because the training data is being used to learn something. Okay, so this is just the representative data set, housing data set. So what we have in this data set, we are having here first 4 columns. Those are actually representing my input X. So size of house, number of bedrooms, number of bathrooms, and the data whether the house is newly renovated. So these 4 are the parameters, these 4 are the properties of the house. These 4 are the attributes for every house. And I know the values for all those attributes for the houses, different houses. So here we have listed the values for 6 houses. So I know this X and also I know the Y. So what actually I am going to predict? This is my Y. Price is my Y. So based on this data, I want to predict the price. And that is why such kind of a data X comma Y is input for my supervised learning algorithm. Okay. So price is Y and these 4 attributes are comprising this X. As I am having 4 different values in my X, the popular terminology is this is forming a vector of values. So in my vector for one house I am having 4 values. Okay, so this is my input vector X. So for every house I am having those values for X and the associated output Y. So based on such kind of data I am going to train my system. So I'll be using some learning algorithm, and based on those learning algorithms I'll be preparing the model, and whenever the new input X is provided to my model. So in this example, new input would comprise of a vector of 4 values: size of house, number of bedrooms, number of bathrooms, and whether the house is renovated or not. So as new input, I'll be providing 4 such values. Okay, and those 4 values are not available in my training data set. Some new unknown data I'll be providing, and based on this model, or this model is being used to predict now the price for this new input. So in this case, my output y is the price. So my system will predict the price for that particular house. Once I provide the values for x, x is a vector comprising of these 4 values. Any doubts so far? Yes.
No, ma'am.
May I proceed?
Yes.
Okay. Now, let us have one more example. So let us say that we would like to build an application for authentication of banknotes. Okay. So what we mean by that? Suppose we are having the banknotes and we would like to find out, or banknotes in the form of, say, images. So we are having the image of a banknote. Okay. And we would like to find out whether it is authenticated or not. Okay. So if it is authenticated, we say that the class is 1. If it is not authenticated, then we say that the class is 0. So this is a kind of binary classification. Either I'll be having class as true, or I'll be having the class as false. The banknote is authenticated or banknote is not authenticated. Okay. Now, I'm having here, so if I would like to have such kind of a classification, no doubt I'll require some data X. So what that data is, here we are having 4 properties, and these properties are variance, skewness, kurtosis, and entropy. We are not going into the details of how these properties are being extracted right now. Okay, right now we do not want to go into the details, but just assume that related to this application, we are having provided with this data, and this data comprises of, once again, 4 attributes: variance, skewness, kurtosis, and entropy. And associated with these 4 values, we are having the known class of the banknote. So either the class is 0 or the class is 1. And we are having such data available with us. So by making use of this training data, now once again I'm going to train my system. So training will happen and my machine learning algorithm will create a model. Now once again, whenever I will be presenting a new banknote as input, so whenever I am saying new banknote as input, what I'll be providing as input? I'll be providing the values for these parameters. So these 4 parameters are X, and this class is Y. So I'll be providing 4 parameters X for my unknown data, for new input. Okay, and my model will predict the output, whether the banknote is authenticated, yes or no. So output would be either class 0 or class 1. Okay, so we have gone through 2 different kinds of applications as an example. Now, in the first application, our output Y actually a value, a continuous value. And if my output y is a continuous value, then the problem is known as regression problem. Whereas if my output y is value, that means it is a label 0, 1, or maybe if it more than 2 classes are there, then 0, 1, 2, 3, yes, no, true, false, something like that. Okay, so if I am having the output as a discrete value, then the problem is classification problem. So under supervised learning, we are having both kinds of problems to be solved: regression problems and classification problems. In regression problems, we are predicting the output which is continuous value. Whereas in classification problem, we are predicting the output which is a class or a label for that data. Am I clear? If you have any doubts, please let me know. Hello?
Can you repeat the regression and classification term?
Voice is not clear. Hello? Repeat your question. Is there any doubt? Please go ahead with the doubts. May I ask Anirudh? Anirudh Magdum, are you there?
Yes, ma'am.
Okay. So have you understood the concept?
Yes, ma'am. When values of y continuous, then it is called as regression. When it is only two types, yes or no, zero or no, it is as classification. Commands.
Okay, great. So can you give me one example of a regression problem? Any one example that comes in your mind?
No idea, ma'am. Sorry.
So if you have understood the concept, you may think of such kind of application. Na?
Ma'am.
So just think of what kind of application we may have under regression. Anybody else who would like to answer my question? Any application for regression that comes in your mind?
Predicting house prices.
So we have gone through that application actually, predicting the house price. Any application other than that?
Weather forecasting.
Weather forecasting. Okay. So what you are going to predict?
Weather. Mhm.
Yes.
We are giving the data for previous 10 to 6 days. Then we are predicting the weather of next week.
Okay. So whether it will give you the continuous value, what kind of continuous value you are expecting? Say for example, nowadays we are having the rainy season, right? So maybe based on the history or maybe based on the previous data, my machine learning algorithm will predict the
With,
what would be the rain today in the form
yes.
of millimeters, correct na? So 10 millimeter
Yes.
rain or whatever, maybe 20 millimeter, whatever, right? So that is actually the continuous value that we may predict for this application. Okay, anybody who can give me the example for classification, any application? Yes. May I ask Rutuja Patil, roll number 76. Rutuja, are you there? Rutuja Patil?
Yes, ma'am.
So, can you give me one application for classification? Just think of. Anybody else?
Email spam detection.
Okay, yes. So, what is the problem statement? What you are going to do?
We
What
are
are the classes?
providing the labeled emails, and from that we are predicting the next email will be spam or not, yes or no type.
Okay. So, the classification problem is detecting whether the email is spam or not spam. So, this is a classification problem. So, in advance, we are going to provide the similar kind of data wherein we'll be having some attribute values X and the class of the email Y, that is either 0 or 1 spam or not spam. And based on this kind of a data, we are going to train our model by making use of a learning algorithm. And once the model is created, whenever the new input we are going to provide, it will give me the class of the email, whether email is spam or non-spam. Okay, good. So I hope you must have understood now the concept of supervised learning, what we mean by regression and what we mean by classification. Okay, so may I proceed?
Yes, ma'am.
Yes, ma'am.
Okay, so let us see now some mathematical formulation for supervised learning. Okay, so under supervised learning, we are defining a model. As I mentioned, our model is nothing but a mathematical function with some set of parameters. Okay, so our model is described like y is equal to h of x given theta. So what we mean by that, this h is nothing but a mathematical function and that is known as the model. Okay, so this h is the model and the thetas are the parameters. Those are being used to define this model. And x is my input. So this h, function h, is a function of... Hello? Am I audible?
Yes, ma'am.
Okay. So we are having or we are describing our supervised learning algorithm in the form of a mathematical model now. So model y is equal to h of x given theta. So h is the model or the output y is described in the terms of a function of my input x and the parameters theta. So y is equal to h of x. X is my input. So output is described as a function of input. Output y is described as the function of input x. And to build that model, I'll be using some parameters. Those are theta parameters. And as I mentioned, the problem is stated as regression problem if my output y is continuous or a number. And it is a problem of classification if y, that is output, is a class code. For example, 0, 1 or something like that. given theta is the regression function if the problem is of regression, and if the problem is of classification, then this mathematical model or the function is known as the discriminant function. So if the problem is the regression problem, I'll be having this function h called as the regression function, and if the problem is classification problem, then I'll call this function h as the discriminant function. So I hope you must have understood the concept. I'll repeat once again. To describe now a mathematical model, right, for supervised learning, I'll be having this expression y is equal to h of x given theta. So my output y is a function of input x, right? So what are those theta? Whenever I'm building a model, I'm using some algorithm, and to implement that algorithm, I need to make use of some parameters. So theta actually is describing the set of parameters. So ultimately my model will be y equal to h of x given theta, right? H is the mathematical function, and this mathematical function actually is providing me y, that is the output. So if the problem is regression problem, then my y would be a number, a continuous value, and if my function is, or if my problem is classification problem, then output y is a class code or a label like 0, 1 and so on. If my function, if my problem is regression problem, then this function h is called as regression function. If my problem is, or if my model is the classification model, then the function h is called as discriminant function. Okay? Am I clear? If you have any doubts, please let me know. Yes. Any doubt so far?
No, ma'am.
Okay. So let's proceed with the methods under supervised learning. Some methods under regression. We are having linear regression, both simple or multiple linear regression. We are having polynomial regression. We are having logistic regression. Under classification, we may have decision tree classifier, random forest classifier, k-nearest neighbor classifier, artificial neural network classifier, or support vector machine classifier. Okay, so these are various algorithms, or these are various methods. Those come under supervised learning, and we are going to focus upon almost all those methods, right? Even though logistic regression is mentioned as the regression method many times, we'll see later, the logistic regression is useful for classification tasks also, or it has basically been used dominantly for classification tasks. We'll see later how that works. We are having that included in our syllabus. So this is for your information. These are various kinds of regression methods and the classification methods. Okay, so I hope you have understood the concept of supervised learning. So we need to focus upon the other learning algorithms as well. So let's focus upon unsupervised learning today, and then we'll stop. Okay, so let's briefly go through unsupervised learning mechanism. So on screen, you are able to see the diagrammatic representation of unsupervised learning. So as we have seen already, in unsupervised learning, our data comprises of only X. So we know the inputs, we do not know the labels, we do not know output Y in case of unsupervised learning. So this data is being provided to my algorithm, learning algorithm, and my learning algorithm will group the similar data items together. So whatever is my X, this X is being grouped into various clusters. These groups are known as the clusters, right? So in unsupervised learning, I am providing unlabeled data X, I am providing unlabeled data. So I know only X, I do not know Y. Okay, I do not know anything about the class, or I do not know anything about the prediction for that X. And whenever I am providing such data set to my learning algorithm, my learning algorithm will learn about the similarity among that data, and based on that similarity, the algorithm will cluster that data into several groups. So cluster is nothing but the group. As I mentioned earlier, we have seen the example, like all the students in my class, I would like to cluster those students. I would like to group those students in 3 categories with respect to 3 disciplines. Right? So I'll be providing input X. I'm not aware about their branch. I'm not aware of the branch of the student. So one input belongs to one student. Okay? So I'm having such n inputs in my data set. I'll be providing that to my learning algorithm, and my learning algorithm will learn the similarity based on whatever input I'm providing, and accordingly my algorithm will try to segregate that data. So my algorithm will form 3 groups, 3 clusters. One cluster related to electrical department, another cluster related to electronics department, and the third cluster related to the aeronautical students. So it is possible for me to make use of unsupervised learning algorithm to cluster the data, to group the data. Am I clear? Under unsupervised learning algorithms, we are going to focus upon in this course k-means clustering and also hierarchical clustering. So these algorithms, our unit number 6 is dedicated for unsupervised learning. Am I clear? Yes?
Yes, ma'am.
Okay, fine. So today we are going to conclude our session. In the next class, we'll be focusing upon semi-supervised learning and reinforcement learning. Okay, so let's stop today. If you have any doubts, please let me know. Any doubts? Okay, so let's conclude the session. Thank you very much. I'll be posting the link for a quiz, and you are supposed to respond to the quiz in next 10 minutes. Okay, so thank you.